When sizing conductors for a continuous load, it's crucial to adhere to the National Electrical Code (NEC) requirements. Typically, NEC Section 215.2a dictates that feeder conductors must have an ampacity not less than 125% of the continuous load. This means you would multiply the continuous load by 1.25 to determine the minimum required ampacity of the conductors. However, there's an exception to this rule. The exception to 215.2a addresses situations where the overcurrent protected device, such as a circuit breaker, is rated for 100% of the continuous load. If the circuit breaker is specifically listed and labeled as being suitable for operation at 100% of its rating, then the conductors are only required to be rated for the continuous load itself, without the need for the 125% upsize factor. This exception is significant because it allows for the use of smaller conductors in certain applications, potentially reducing material costs and installation complexity. In the scenario provided, the circuit breaker is rated for 800 amps frame/800 amps strip, which indicates that it is a 100% rated circuit breaker. This means it's designed and tested to carry its full rated current continuously without exceeding temperature limits or posing a safety hazard. Because the circuit breaker is 100% rated, the conductors supplying the load only need to be rated for the 800 amps continuous load. It is not necessary to apply the 1.25 multiplier. The question specifies that two 600 kcmil conductors per phase are being considered. These conductors, in parallel, must have a combined ampacity of at least 800 amps. Consulting NEC Table 310.16, which provides ampacity ratings for insulated conductors rated up to 2000 volts, reveals the ampacity of 600 kcmil copper conductors based on insulation type and temperature rating. For example, a 600 kcmil copper conductor with a 75 degrees Celsius insulation rating, such as THHN or THWM-2 in a dry location, typically has an ampacity of around 400 amps. Since two of these conductors are used in parallel per phase, their combined ampacity is 800 amps, which meets the requirement for the 800 amps continuous load. Now let's consider some additional factors to ensure a safe and compliant installation. Firstly, conductor ampacity is affected by ambient temperature and the number of current-carrying conductors in a raceway or cable. If the ambient temperature is higher than 30 degrees Celsius, or if there are more than 3 current-carrying conductors in a raceway, adjustment factors must be applied to the conductor ampacity per NEC Table 310.15b3 and 310.15 colon. These adjustment factors reduce the allowable ampacity of the conductors to prevent overheating. It's essential to perform these calculations accurately to ensure the conductors are adequately sized for the actual operating conditions. Secondly, the termination points of the conductors must also be considered. Terminals on equipment, such as the circuit breaker and the motor control center (MCC), must be rated for the conductor temperature. Typically, equipment is rated for 75 degrees Celsius conductors. Therefore, even if the conductors themselves have a higher temperature rating, such as 90 degrees Celsius, the ampacity used for calculations must be based on the 75 degrees Celsius rating, unless the equipment is specifically listed and labeled for use with high temperature conductors. Thirdly, the motor control center (MCC) is rated for 800 amps continuous. This means that the MCC busbars, terminals, and other components are designed to safely carry 800 amps continuously. The incoming feeder conductors must be properly sized and connected to the MCC to ensure that the MCC rating is not exceeded. The conductors must terminate within the MCC in a manner that is consistent with the MCC manufacturer's instructions and the NEC requirements. Fourthly, it's important to ensure that the conductors are properly protected against overcurrent. The 800 amp circuit breaker provides this protection. The circuit breaker is designed to trip and interrupt the circuit if the current exceeds its rating, preventing damage to the conductors and equipment. The circuit breaker must have an interrupting rating sufficient for the available fault current at the MCC. The interrupting rating is the maximum fault current that the circuit breaker can safely interrupt without failing. A short circuit study should be performed to determine the available fault current at the MCC to ensure that the circuit breaker's interrupting rating is adequate. Fifthly, conductor installation methods play a critical role in ensuring proper ampacity. Conductors installed in free air have a higher ampacity than conductors installed in conduit or cable trays. This is because conductors in free air can dissipate heat more effectively. The NEC provides tables that specify the ampacity of conductors based on different installation methods. The installation method must be carefully considered when selecting conductors to ensure that they are adequately sized for the application. Sixthly, voltage drop is another important factor to consider when sizing conductors. Voltage drop is the reduction in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for feeders and 5% for branch circuits. Voltage drop can be calculated using Ohm's law and the conductor's resistance per unit length. Larger conductors have lower resistance and therefore result in less voltage drop. Seventhly, grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, allowing the overcurrent protective device to trip and clear the fault. Bonding ensures that all metal parts of the electrical system are at the same potential, reducing the risk of electric shock. The NEC specifies detailed requirements for grounding and bonding. These requirements must be carefully followed to ensure a safe electrical system. Eighthly, documentation is crucial for any electrical installation. Accurate records of conductor sizes, circuit breaker ratings, and other relevant information should be maintained for future reference. This documentation can be helpful for troubleshooting problems, performing maintenance, and making future modifications to the electrical system. Ninthly, periodic inspections and maintenance are essential for ensuring the continued safe operation of the electrical system. Conductors, circuit breakers, and other components should be inspected regularly for signs of damage or wear. Any problems should be addressed promptly to prevent potential hazards. Tenthly, it's always best to consult with a qualified electrical engineer or electrician when designing and installing electrical systems. These professionals have the knowledge and experience to ensure that the installation is safe, compliant, and reliable. The NEC is a complex document, and it's easy to make mistakes if you're not familiar with its requirements. Professional guidance can help avoid costly errors and ensure a successful installation. In summary, when using a 100% rated circuit breaker, the conductors supplying the load only need to be rated for the continuous load current according to the exception to NEC 215.2 AON. However, it's crucial to consider other factors such as ambient temperature, the number of current carrying conductors, termination temperature ratings, voltage drop, grounding, bonding, and proper installation methods to ensure a safe and compliant electrical system. Consulting with qualified professionals and maintaining accurate documentation are also essential for long-term reliability and safety. This information is for educational purposes only and does not constitute professional engineering advice. Always consult with a qualified electrical engineer or electrician before making any decisions about electrical installations. Understanding the NEC requirements for conductor sizing, especially when dealing with 100% rated circuit breakers, is crucial for ensuring a safe and efficient electrical system. By carefully considering all relevant factors and seeking professional guidance when needed, you can ensure that your electrical installations meet the highest standards of safety and performance.